and welcome to niftyDuck. Tom here. Today we are working with positions, so movements, the transform component and vectors. Let's start. Now we are using a moving object. I'm going to show you how to make this cube move in a certain straight direction, then make it be followed by the camera and move right and left with inputs. Go in the empty game object script and delete all commands except the two variables and the initialization of RB. I want that in the void update the cube moves forward with a certain speed. So we need a new variable which defines the speed of the object, right? So up here I'll write public float speed. I make it public because I want to change it after in the inspector. Okay, we have now the speed variable. Inside the void update rb.velocity equals to vector3.forward multiplied by speed multiplied by time.delta time. Here I've written rb.velocity and it's the same of cube.getComponent rigidbody.velocity etc. .velocity is a parameter that is inside the inspector. In fact, if you watch it in Unity, inside the rigid body component, click on info and you'll see velocity. Velocity is the parameter that permits you to move the object in a certain direction. So you see x, y, z. If you return in Visual Studio, you'll see this vector3.forward. Let's put Unity at the half of the screen and listen carefully. This x, y, and z are called vector3. A vector3 defines the position or the direction of a certain object. When you write it, you must define the x, y, and z position, but you can also write vector3.forward, or up, or down, or right, etc. And it will automatically give you the direction. It's called vector3 because it's a 3D parameter. For example, if you are in a 2D game and you want to move something, you'll have to write vector2 because in 2D games there are only two dimensions, x and y. But we are in a 3D space, so vector3.forward multiplied by speed. Let's comment time.delta time to not make confusion. Now our cube every frame will move forward with this speed, but there is a problem. Let's suppose that your game is too heavy and you're going at 10 frames per second. Every frame your cube will move, but not smoothly, because the speed will depend by the frames, right? So every time you move something, you should write time.delta time. So your cube will depend by the time and not by the frames. So if you go at 10 FPS or 60 FPS, the speed won't change. Let's put Unity at full screen and put the speed at 500s and start the game. Alright, finally it works. You have now learned how to move an object in a certain direction with the velocity, but let's work a bit more with the vector. I want that this camera follows the cube, so open Visual Studio. We have to define what the camera is, so public, camera, main camera. Now we have the camera variable. I can code inside the void update, but wait. The camera is something that follows another object and doesn't move independently. I must insert a new void here, the void late update. This is the exact same of the update, but it gets called a bit later of it. So in every frame the cube will move and immediately later the camera will move in the object direction. Okay, I'll put Unity at the half of the screen and see the camera's inspector. First, we must define the subject of the instruction, so main camera, and then the component that we want to control, .transform. But why don't we write as always main camera.getComponent transform? Well, it's the same. For the transform component, it's not necessary to write every time getComponent. But Unity allows you to also write it like this. Now you see that the transform component is subdivided in position, rotation and scale. I want to move the main camera, so dot position and equals to. With this, I'm going to define the position of the main camera. At left, we have a position value, so we can't write here an integer or a float, but it must be a position value. We could write cube.transform.position, so the main camera's position will be the same of the cube's one. But the view of the game will penetrate inside of the cube model, and we don't want that. So we must define a certain distance between the cube and the camera, like a third-person game. Equals to new vector3, parentheses. New because it's a customized position and not a default one like vector3.forward. Inside the parentheses, you must indicate three values, x, y, and z. The first, main camera.transform.position.x, because I want that the x position of the main camera won't be influenced by the cube's one. Then comma, cube.transform.position.y plus 5. So the camera will be higher than the cube with a value of 5. Cube.transform.position.z minus 15, because it must be behind the cube. Save and initialize the main camera in Unity by dragging and dropping it inside the space of the variable. Run the game and see what happens. If you watch the game view, you won't notice anything, but open the scene view and you'll see that the camera is following the player. You've learned how to use vectors and velocity, but let's make the cube move right or left with inputs. Return in Visual Studio and go in the void update. We need a float variable that recognizes if you're clicking A or D on your keyboard, and I'll write it inside the void update, because that variable won't be used in other voids. Float move equals to. And we want to define the axis of movement, so input dot get axis parenthesis horizontal between double apexes. And with this, Unity will automatically know that if you press right or left arrow or A or D, the player must move. Then, under this instruction, let's define the movement. Cube.transform.position equals to new vector3 parenthesis cube.transform.position.x plus move. Move will be positive or negative, and it will depend on what you press. Comma cube.transform.position.y and comma cube.transform.position.z to make the other ones uninfluenced by inputs. Save and see the result in Unity. Well done! You have now created a moving player. I know it's a bit fast, but if you want to make it slower, all you have to do is declaring a new variable which defines the speed of the object and multiplying it for the move variable and for time.delta time. I'll show you right now. Declare a private float moving speed and give it, for example, the value of 15. In the void update inside the vector3, multiply the move float for the moving speed 1 and then for time.delta time. If you watch Unity, you'll notice that the speed is now normal and you can change it as you want. The video is ended here. Subscribe and click the bell to get notifications, and see you in the next video. Bye from niftyDuck.